That's right. Yes, in this easy 1, 2, 3 tutorial, you're going to learn how to use a magic square. All right. But wait, there's more. Act now. It's handy, Jumbo Deluxe. Likely to come up hard at high speeds. Okay. So actual is going to be always on the left side. Okay. And then, so we're using our drawing here, our pic, our photo. So let's call it a pic. That's fine. All right. And we're going to set up our magic square. So again, you want your target quantity in the top left corner of the square. It just makes the mathy math part a lot easier to deal with. All right. So since this is at 400x, we know, and we're going to set up our formula. So what you want to do always when you're doing scientific calculations is set up your formula first. All right. When you do the medical college admissions test, and you guys who are aspiring doctors, they have multiple choice questions, and there's zero math calculations at all. They actually give you formulas. Which formula is the correct answer, or the correct one that's going to solve this question. So being able to manipulate a formula is the real skill. From that point, we just call it plug and chug. So you plug your numbers in, you chug them out, and away you go. Okay? So that part's the easy part. But there is some formatting here that I want you to follow. So always set up your formula first. All right? This is the most important. So we're going to go the length of the amoeba. That's our target. And notice that I've changed the specimen name. Yesterday I was doing, we were doing a paramecium. Okay, it's cute. I've had it in the past where students just put L paramecium no matter what specimen you're looking at. I'm like, that's paramecium came out of your mouth there. We're studying cheek cells. Okay, so it's different. So you want to always put the specimen in subscripts. What goes underneath? In the bottom part, bottom left part of the square. Diameter of field of view. Okay, so you want to be very specific. DFOV. And then put your magnification there. So that will trigger your memory from the chart, which you've remembered, of what the diameters are for each magnification. All right? So those symbols are really important in scientific literacy. So we're going to go length of amoeba. And I'm going to put even in pick there. Just to, again, remind myself. Why? Because I'm a forgetful dude. All right? I need to write everything down. And in writing those little steps down, it takes it out of my brain and puts it onto paper so I don't have to hold as much in my brain. Does that make sense? Okay, so it's sort of a trade-off. The investment of writing all your steps out is the payoff. The other payoff is this. If you make an error at the end, then I can say, hey, they set everything up, but they must have punched it in their calculator wrong. Okay? Whereas if you just jump from one thing to the other, then you're showing me, you know, either laziness or lack of understanding or both. I'm not sure. And I can't differentiate that. And this is, again, it's with that evaluation part where I can give the part marks. So I can actually prove or justify, no, they set everything up right. They just had a little minor error. You know, so then I can give you like a 4 minus instead of, you know, going, oh, it's wrong. Does that make sense? Okay, so show your work. But I'm going to teach you always what I expect. All right? So DFOV, and we're using our picture, so we're going to go pick. All right? And that can be capitals or whatever. It's just communicating what we're after. All right? Now, like good formatting in math, we want to put our equal sign right underneath. Okay? What I'm going to do is I'm just going to extend this page here. Diameter of field of view. So FOV is the short form for field of view, and little d in science and math is for diameter. Sometimes it's used for distance, and if there's a little arrow above it in physics, it's called displacement. That's a whole other thing. All right. So we don't know, our unknown is the length of the amoeba. So we're going to keep that as an unknown, all right? In that awful world of math, that would be what we call x, the variable. We don't know. It's going to vary from one person to another. So now that word actually makes sense. It's a variable, depending on which amoeba you're measuring. But DFOV, diameter field of view at 400x, is not varying, and we've all agreed, based on our previous measurements, that and the relationships between magnifications, that this is 450 microns. When you substitute your numbers in, put them in brackets. It's an extra step. It is meticulous. It is maybe even a little bit of a pain in the butt. Why do we have to do that? Just please trust me. Okay? From a guy who, you know, made a lot of mistakes because of cutting little corners here and there and having bigger problems happen, let me give you a little mistake story. So one of my fellow colleagues, when I was doing research, I was making genetically engineered mice. We were studying blood vessel development, and So I was taking these little test tubes, about that big, okay, about like, I don't know, about an inch. That's how big the test tubes are. And he had his labeled, and I was trying to take a piece out of that, his DNA, and paste it to mine, right? Well, it turned out that he didn't label his test tube correctly. He had a little boo-boo. We only discovered that once my mice were made and they were growing and I was breeding them and they weren't inheriting at the proper ratio, which you're actually going to learn about. And when something's off here, and we realized he gave me the wrong DNA and the whole project had to be scrapped. It was an entire year of my life gone. Like the whole year, gone. The whole project terminated because he didn't label his test tube correctly. All that work thrown out. And those mice were sacrificed for nothing, which was sort of a shame, you know? And it was just a boo. He didn't mean. He was like, sorry, like, how do you even apologize for that? That's a person's life. It was okay, though, you know? So it's cute when I'm doing something and I write something and I erase it and someone goes, oh, like you have to restart. I'm going, sure. Thank you. All right, well, I hope that made it in. Mom? It's my mom. All right, so length of amoeba in the pick. This is where we got to take our ruler and do our measurements, right? So we're going to go from end to end. So I'm going to put that little 0 there. Okay, now what's cool about this ruler is I can go like that. It's a little more precise. Okay, and that's looking to be 6.5 to the end there. Okay, so we're saying from one end to the other. And let's just pretend this is actually centimeters, but obviously this isn't millimeters. This ruler doesn't even have units, but yours will have units. And again, you can measure them and express them in either centimeters with a decimal or millimeters. Is that fair? Okay, so if you want to convert it either way, but keep it consistent. So for this one, we're going to say it says 6.5. It's like right on that point there, and that's fine. Now, I'm not going to put units because I don't even know what these units are, technically. These are not millimeters. They're actually bigger than that, but that's okay. But you get, I'm hoping you get the idea. Now we're going to take that 0 and line it right up with the edge of that circle. And I'm going to drag that ruler down just to see if I want to be as precise and accurate as possible. I'm going to say 7.6, maybe 7.7. Let's see if I can't drag it down to 7.7. There. No, it's holding at 7.6. That's fine. Okay. Now, hypothetically, in your calculations, and let's just pretend for the sake of argument that this was indeed centimeters. Okay, so I actually put my units in. It's really important that you include all of your units because when you're actually running through your calculations and you do your math, the end unit that you end up mathematically that cancels out ought to be the correct unit. And if it's not, then your formula was set up incorrectly or your calculation was set up incorrectly. And that's one of the giveaways that you know that it's not jiving, okay? So we see the magic square. It's a 2x2 square, very simple, all right? Now, obviously the centimeters are going to cancel themselves out. Why'd you bother putting them in the first place? It's just important. It just shows me that you measured and you know what you're measuring. And you want to be meticulous in science. And it also has to be reproducible, meaning that if someone else grabbed your thing and did exactly the same thing, they'd get exactly the same result. That's where we get our reliability in science. That's where we get our confidence from science. All right, now, I want you to think about this from a practical point of view. This relationship here is really going to create a decimal value, isn't it? So it's a fraction, okay? So that 6.5 out of 7.5 tells us, and I'm going to get my calculator out because I haven't memorized, so I'm going to go 6.5 divided by 7.5. All right, so it says 0.86666 repeated, so 0.87. So what that means is that the length of this amoeba in this picture is taking up 87% of the diameter, of the total diameter. Does that make sense from a practical perspective? Okay? And you'll see how this works when you see my drawing there. That's not magnetic. All right? So, leave that number as is, but remember, all we're doing is cross-multiplying. Okay? So we're going to show our steps. So formula, substitute, calculate, solve. Okay? Whoops. Keep our conventions here. L amoeba. If you want to do it in color, because that's just more fun and artistic, go for it. You don't have to. I like to. And now we can just drop that bracket. Okay, but I'm going to keep that bracket for the 6.5 to show the function of multiplication. So the length of my amoeba from one end to the other, as long as I can get it, like the maximum length this amoeba has stretched itself is really what we're asking. We're going to round off to the nearest micron, so 390 is what it comes out to. All right. Now keep in mind, it's really critical that your final answer has the symbol, the equal sign, the quantity, and then the unit. That's proper scientific convention calculation. So when I say show me a properly formatted calculation, what I expect to see is that format. Formula, substitute your numbers, manipulate your numbers, and give me your final answer. Okay? We're going to use the exact same process with the drawing. Okay? With the drawing. Here we go. Too fast. Well, I'm recording this, so you can check it out after. It'll be on the blog. Okay. Let me get my ruler here. Grab an end, we'll just lay it out flat. That's fine. Whoop, come back. There we go. Okay, drag this dude over here. So, the circle of my drawing is actually right at 8.0. Okay, so I'm going to set up my magic square. Same process. Okay, but instead of, so actual was red, we said. Okay, DFOV 400, L amoeba. Okay, we're going to use blue for drawing. Okay. So I just measured that to be 8.0. Let's pretend that's centimeters, actually. But we know it's not. L amoeba. 450 microns. That has not changed. Now I need to measure the length of my drawing. Okay, so I'm going to take my 0 mark, and I'm going to lock that there, and I'm going to grab my ruler and just twist it down to that edge there. So 7, almost 7. So based on what I'm estimating here, I can actually estimate, because I can see enough space between those millimeter markings with my ruler, but let's pretend you can't. Okay, so we'd have to pick it. There. Actually, it's right on 7. That's fine. Okay, plug and chug, right? Oh, brackets. All right. Now, if you're cool with cross multiplying and all that, you don't have to show the next step. I will allow you just to jump, because it's just a multiplication and division. But it's actually good to see it, so you know what to do next. Again, this will lower the chances of careless errors. And they happen to all of us all the time. Okay? Every human being. And build in and budget for that. Assume, hey, I might mess this up. So I want to be very careful in my calculations. I worked in a factory once and someone wasn't so careful. All right, I'll finish this up. So finish these for homework and follow this process. This video tutorial will be on the blog. Have a great one, guys. Not bad. Yeah, finish it up for homework, those calculations.